Hi guys, good evening. Thank you very much for tuning into my channel. Today I'd like to tell you about something I purchased on an online internet classified site. In Canada it's called Kijiji. I don't know if they have this in the United States or other countries. Well, I know they do, but I don't know how popular it is there. So this is the one we use. I didn't get the original box. This is from a listing on eBay, but I guess this is the original box for the Realistic Pro-2020 20-channel scanner receiver. So here's the exact ad of the product I purchased. Radio scanner and antenna, and several hours ago today I went to a fellow's house and purchased the scanner from him. I didn't ask him a whole lot of questions. I gave him pretty much what he was asking. It was such a good price I felt it was unfair to try and bargain. Anyway, this is his exact ad. Realistic Pro 2020 radio scanner plus antenna. It's not the original antenna. It's one that plugs into the back. There was an original antenna that probably plugged in here, but it's probably been broken off at some point over the years. There's a limited frequency range, so 30 to 50 megahertz, then 108 to 136 megahertz. Well, you can read the rest. What was most interesting to me is the 400 megahertz range, because I think it might be fun to put a discriminator tap on this scanner and see if I can get some digital decoding of DMR transmissions from this. Well, I haven't done that yet, and that might take a bit of work, so it may or may not happen. This is the serial plate on the side of my radio. Realistic Mod 2011-12 Pro 2020. It shows the frequency range, the mains electricity here in Canada and North America. It says basically 12 volts, I guess a little higher, so you could probably use this in your car, although this is a really hefty size unit. Originally this was made in Japan, distributed in Canada, in Barrie, Ontario. I'm not exactly sure what direction this video is going to take. It might be slightly boring. It's a little bit of information gathering for myself. So here's just the Google image search of the Pro 2020 radio scanner. When I searched for this radio on YouTube, one of the first videos that came up was actually a Canadian guy. At least judging by his accent, it sounds like he's from the East Coast, and he has a very popular channel, and he's modifying a Realistic Pro 2020. And it was a really good video. He's got he's got a pretty good review or thumbs up rating on his video. Cutting it off a little bit. I won't recap his whole video, but it's a pretty good one because it covers a few relatively easy and simple mods that you can make yourself. Okay, the first one he does is like an antenna jack mod. It has this old style of antenna jack, which is still the same on my scanner too, and he basically just swaps this out for a BNC connector. Here he's got it done here. One of the next things that he talks about in his video is how there are these resistors, and depending on the pattern in which they're wired in, you can actually adjust the frequency range. Particularly the 30 to 50 megahertz range can be increased to the European bandwidth, and he even drew it on a piece of paper. So like 30 to 50 megahertz to 68 to 88 megahertz. Okay, so I like to give credit where credit is due. So the channel that you might like to check out is Radio Nut 63, and in particular this Realistic Pro 2020 radio. Especially if you own this and you want to see a very straightforward mod that you might like to try yourself. Okay, so I went ahead and I took some pictures of my radio, and I just wanted to study it a little bit and understand just exactly how this radio is working. I am fairly familiar with electronics, but I'm no expert. So I thought, well, maybe I'd like to try looking up some of the integrated circuits. Well, before I get into that, if you go onto Google, type in Realistic 2020 Scanner Manual. Here it is here. And maybe there's another manual out there with pictures, but this isn't the one. And in the least, it'll give you a parts list. And this was generated in 2005, so I don't think that this is an original manual, but it seems to be one of the popular ones out there. And this is actually something that the fellow who sold me this scanner actually printed out and gave to me. And it talks about kind of the basic operation. And I'm hoping to get a better camera soon. So this kind of information would have been good to demonstrate on a video. And I fully well would have done that, but again, my camera's kind of crappy right now. But anyway, I took a picture. This is exactly the scanner I have, and I'd like to look up some of these ICs. I already tried to Google search this one, the GRE7954. I didn't find a whole lot of information on it, but I did find a data sheet for the TC5501P. So this is marked as IC2 on the board. So I'll just read. Toshiba MOS Memory Products. Description. The TC5501PD is a fully static read-write memory organized as 256 words by 4 bits using CMOS technology. And forgive me because I did say this video might be a little bit boring, but if you own the scanner, it might not be. Because of ultra-low power dissipation, the TC5501PD can be used as battery-operated portable memory system and also as a non-volatile memory with battery backup. The TC551PD operates from a single 5-volt power supply with a static operation so that no refresh periods are required. This simplifies power supply circuit design. The 3-state outputs simplify the memory expansion, making the TC551PD suitable for use in a microprocessor peripheral memory. Since the minimum data retention voltage is 2 volts, the battery backup system needs only simple circuit. By using Toshiba's original C2 MOS technology, the device circuitry is not only simplified, but wide operating margin and noise margin are also realized. The TC5501PD is offered in standard 22-pin plastic and SIRDIP packages, 0.4 inch in width. So here are the features. Low power dissipation, 55 microwatts standby, 83 microwatts operating, or milliwatts operating, single 5-volt power supply, data retention. I already read that in the description. It's got, well, 11 pins on this side, and I guess 22 pins on the other side. These A0 to A7 are marked as address inputs. I guess this is a read-write pin. Pin 8 is the ground. There's inputs and outputs. How does this all work? I'm not going to pretend like I completely understand it. And it's got a block diagram. So all these address buffers go to a decoder. Okay, there's a bit more information. So VDD is the power supply voltage, which is rated at 0.3 to 7 volts. The input voltage 0.3 to 3 volts, output 0 to VDD. So I guess it can put out basically the power supply voltage. Operating temperature, I guess that's like a temperature coefficient. Well, anyway, this is a memory chip. Okay, the next IC I'm going to talk about is this TC4009 UBP. Well, I'm not 100% sure, but I think this is like a 4009 IC. And I could be wrong about this, and then maybe I'm giving you bad information, but this 4009 series IC looks like a hex buffer or hex inverter, and I've actually come across these before. So whatever input you put in, I think it just gives you the opposite out. So if you put in a high, it gives you a low. If you put in a low, it gives you a high. But I could be wrong. I'm going to read the description. I'll zoom in a little bit. These hex buffers are monolithic complementary CMOS integrated circuits. The N and P channel enhancement mode transistors provide a symmetrical circuit with output swings essentially equal to the supply voltage. This results in high noise immunity over a wide supply voltage range. No DC power other than that caused by leakage current is consumed during static conditions. All inputs are protected against static discharge. These gates may be used as hex buffers, CMOS to DTL or TTL interface, or as CMOS current drivers. Conversion ranges are from 3 volts to 15 volts, providing VCC is less than VDD. Okay, so wide supply range is 3 volts to 15 volts. Automotive, data terminals, instrumentation, medical electronics, alarm systems. Dual inline package configuration. This picture looks the same as this one. Okay, so the next chip I'm looking at is like this Texas Instruments one. The J122B, but I think this is the number we want. The SN74L6 or S26N. Well, I did look that up, and yeah, it just looks like a logic chip. And this was one company that makes it. So this is a NAND Gate chip. Here's the pinouts. 14 pins. Here's the schematic. Not going to try to explain that. What are these, like Zener diodes? I'm not sure offhand. Shows the supply voltage is 7 volts. The input voltage is 7 volts. This information is kind of interesting to me because say you wanted to try to identify the different voltage supplies in the circuit. It's kind of neat to know what's running off of what different voltage levels. Recommended operating conditions, 5 volts, I guess. So this IC is running off of a 5 volt supply. Well, I won't read all this, but I guess I've got it on the screen here. And just for reference, in digital electronics, a NAND gate, not AND, is a logic gate which produces an output which is false only if all its inputs are true. Thus, its output is complement to that of an AND gate. So here's a truth table for a NAND gate. When A and B are low, the output is a 1. When A is low and B is high, the output is a 1. When 1 is Okay, so on the list of parts, I didn't see this particular IC8 listed, so I don't know how to look that one up. Okay, the next IC I'll be looking at is the TC5069BP, which is IC4. This one's made by Toshiba. Here it is in the parts list. It's IC4. And I looked it up on our data sheet. I'll try to read the description quickly. TC5068, and I guess there's a 69 one as well. C2 MOS digital integrated circuit, silicon monolithic. I can zoom in a little bit. The TC5068 and 9 are decoders which convert the inputs of BCD codes into the 7-segment display element driving signals. Okay, well that's interesting. So this IC is involved in the display screen, the 7-segment display, which is on the front of the device, at least from what I can tell. Since the segment output is of an open drain structure with high breakdown voltage P-channel FET, these decoders can directly drive fluorescent display tubes. Each of, that would be 7-segment displays they're talking about. Each of 4 input lines contains a latch controlled by a common strobe input to facilitate static drive. Each BL input is used for forcing all the segments to be to the off state. Therefore, the decoders can be applied to the leading 0 suppress. Well, anyway, it says DC supply voltage is capable of 0.5 to 20 volts. Input voltage is VDD, which is 0.5 volts. Output voltage goes up to, like, can't really tell. And here's a picture which shows all of the pinouts. There's a 4-bit latch, and there's BCD to 7-segment decoder. I guess it's using some logic. And yeah, I can pause and understand this better if I want. So that was this chip here. And I already covered this one, which is IC9, which was like the hex inverter one. Ooh, I cut this one off. Well, here's a different picture. I actually captured it. So this IC is the TC5066BP. Okay, so I did manage to find this just by plugging the numbers in on Google. The TC5066BP. So here's the sheet. TC5066BP and the 67 contain 7 independent circuits of buffers in non-inverting type, and the 67 one is the inverting type, as both have the output of an open drain structure with high bleak down voltage. Maybe that's supposed to be breakdown voltage. T-channel MOSFET 50 volts maximum rating. These are suitable for driving fluorescent display tubes and for interfacing with high voltage MOS LSIs. So once again, I think, and I could be so wrong about this, but I think this is dealing with the 7-segment display also. Absolute maximum ratings. So supply voltage can be 0.5 to 20 volts. Input voltage is up to 5 volts. Output voltage is a negative amount to 0.5 volts. Power dissipation, and here's a couple charts. Some more information. And yes, fluorescent display tube driving, I think really is just talking about the 7-segment display, and it shows how this is all hooked up. Okay, so hopefully I learned something. This chip and this chip are both responsible for the 7-segment display, which is down here somewhere. This is a hex inverter. Okay, just a helpful hint. If you're trying to look at the parts list on this particular scanner, sometimes it's good to use the find function on the web browser to pull out parts kind of as you see them in the pictures. Okay, so I'll just start with this one, the TA752-1P. So I guess this is another Toshiba chip, and it looks like kind of like an op-amp because it's like a triangle schematic symbol, but they're probably comparators, which of course I guess is where op-amps actually come from. And well, I'll just read TA7521P, bipolar linear integrated circuit, dual comparator, voltage comparator, TOW circuits package, possible to operate at +3 volts single supply, possible to gain inverted output, large common mode voltage range, absence of latch up. What does this say here? So there's I guess 14 pins. This just shows the dimensions. VCC supply voltage is 18 volts, or does that say 1.8? I think that says, well, I can't tell. So there's the VCC. What's NC stand for? Anyway, you've got outputs, grounds, outputs. Pin 5 is like a comparator. Input, input. Recommended condition supply voltage at 5 to 12 volts. Here's a few graphs. Supply voltage. Okay, let's just say it's at 5 volts, then shows the power dissipation. Okay, so this chip here is a comparator. Okay, here's a side angle view of the same chip here. So maybe I'll look at this one next. This is listed as IC103 on the parts list. Let's copy that. Okay, so once again we're looking at this chip now, and I did find a data sheet for it. This is the TD62501P. It's a Toshiba chip, 7 single driver. The chip series are comprised of 7 or 5 NPN transistor arrays. Okay, so these are kind of like microprocessors. These are drivers. These are like, yeah, microprocessor. I don't know, maybe I'm wrong, but they're an array of transistors. For proper operation, the substrate must be connected to the most negative voltage. Applications include relays, hammer, lamp and display, LED drivers. Features output current, 200 milliamps max. Okay, this shows the pinouts. That's the 62501P-F, so that's the one we're looking at. I don't know, kind of just looks like hex inverters. Okay, never mind, hex inverter. Oh yeah, I guess that's what that is. It's just they're pinned differently. These just kind of go straight across, but it's the same thing. Okay, for reference, the inverter is a basic building block in digital electronics. Multiplexers, decoders, state machines, and other sophisticated digital devices may use inverters. The hex inverter is an integrated circuit that contains 6 inverters. So the next IC I'm looking at is this one back here. And it's close to where the power supply kind of comes in here. So it's this chip up here. Okay, so here's the TC4016BP, which does show up on the parts list. Digital integrated circuit. This chip contains 4 circuits of independent bidirectional switches. When control input cont is placed at B level or high level, when the control input cont is placed at, be careful what I say, when the control input cont is placed at H level, the impedance between the one input and output of switch becomes low, and when cont, maybe control, is placed at low level, it becomes high. This can be used for switching analog and digital signals. Okay, so it shows the dual inline package. I guess this has like surface mount, so this must be a later version. Okay, DC supply voltage goes up to 20 volts. Control input voltage is 0.5. Okay, so here's the pinout diagram, VSS. Okay, for reference, VSS is generally the most negative supply terminal for an IC or a circuit using MOS devices. VDD is the positive supply voltage. S and D refer roughly to the drain and source, so that's like a MOSFET transistor, I think. In a single supply circuit, VSS is usually ground. Okay, so here's VSS, which is pin 7 on this chip, and I guess that just means ground. Input output, output input. These are like control pins. Another control pin goes to the bottom of this. I guess it's like a switch, like a MOSFET transistor maybe. So without being too complicated, I think this is just like an array, I don't know if that's the wrong word, of MOSFET transistors. That's what this circuit is, I think. What do they actually call it? Quad bilateral switch. Okay, so there's 4 quad, 1, 2, 3, 4 switches, probably MOSFETs. And here's some complicated circuit diagrams. Okay, I just used the find search for IC to look up any ICs that I missed in this parts list, and there's this LM34028. Well, here's a picture of something with the similar code, so this looks like a voltage regulator. Here's a data sheet I found. Is this the right number? Well, I don't know. This is the 340A rather than a 340T. I don't know if it's the same thing, but I will read the description. The bunch of these monolithic 3-terminal positive voltage regulators employ internal current limiting thermal shutdown and safe area compensation, making them essentially indestructible. If adequate heat sinking is provided, they can deliver over 1 amp output current. They are intended as fixed voltage regulators in a wide range of applications, including local on-card regulation for elimination of noise and distribution problems associated with single-point regulation. I'll skip down here. The 5 volt, 12 volt, and 15 volt regulator options are available. Well, kind of as I suspected, I looked up the number, and I guess the 8 probably signifies that it's 8 volts, even though this is in Spanish. Well, the parts list even says that it's an 8 volt regulator. So I guess